Today we are doing lesson 1-8, words into symbols. And I've written down the first example here, so you're probably going to want to pause and write it down. For A through, there's actually E, we are translating each of these sentences into using numbers and symbols. So they're written as sentences, and we're going to use numbers and symbols to write them down. Today's lesson, you're going to want to make sure that you're paying extra careful attention to, because we are going to be doing word problems today. So you're going to have your book open to page 46, and you are going to have to follow along with me in order to make sure that you're ready for your classwork tomorrow. Looking at A, it says a number decreased by 2. Well, you want to highlight the key word here, which is decreased. So a number, we'll make it the variable x, decreased by, which means subtraction, 2. So we translated in the sentence into numbers and symbols. 5 more than 3 times a number. So whenever you have more than or less than, it's the opposite of what you think. This sounds like it reads 5 plus 3 times a number. But more than and less than, you need to switch these around, and it's actually 3x plus 5. So 5 more than 3 times a number is not this one. It's 3x plus 5. So more than, less than, you got to remember that you switch those around. The difference between a number and its squared. Difference is your key word. So that means subtraction. So the difference between a number would be x, and its squared, and it's that number squared. So x minus x squared. D, the sum of twice a number. So we have sum, and that means you're going to be adding. So twice a number and 6. So the sum of twice a number and 6. 2x plus 6. You have consecutive integers, which are like -3, -2, -1, 0, 1, 2, and 3, and those are just numbers on a number line. You also have even integers, which is -4, -2, 0, 2, 4, 6, 8, 10, 12, all your even integers. And odd, -3, -1, 1, 3, 5, and so on. What you're going to need to understand about consecutive numbers is sometimes it wants it written in general form. So when it says find 3 consecutive even integers or 3 consecutive integers, and it doesn't tell you which ones you're looking for, you have to start with the variable x or n or whatever you want it to be. So I'm going to start with x, and if I wanted to find the next consecutive integer, I would have to add 1 to this. So let's say x was 2. What would I have to add to 2 to get the next consecutive integer, which is 3? I would have to add 1. Now, again, if x was 2, how would I get the next consecutive integer, which would be 4? Well, I would have 1 plus 2. I'm sorry, 1, I meant to say 3. I think I said it wrong. Oh, we're starting with 2. Okay, so to get 4. Sorry, I was thinking we're starting with 1. So let me say that one more time. So if you had 2 as what x equals, you'd have 2. 2 plus 1 is 3. 2 plus 2 is 4. And it works no matter where you start with. Let's say I started with x equals 1. I plug a 1 in here. 1, okay, so I know if I start with 1, the next one's 2. Well, 1 plus 1 is 2. 1 plus 2 is 3. 1 plus 3 is 4. So it doesn't matter which integer you plug in, even if they're negative. Let's say I started with -3. If I plug in -3 here, I would have -3 plus 1 is -2. -3 plus 2 is -1. -3 plus 3 is 0. So again, it doesn't matter what x is, you will always get consecutive integers when you have this type of form. You could also get x minus 1. If it said, for example, on your homework or when you're doing your classwork, because I know there's one like this, that x is the biggest, that means that you have to subtract. So you'd have x minus 1, x minus 2, and so on. So they can be plus or minus depending on what the directions give you. Let's look at even integers. Let's start with 2. How would I get 4? Well, I would have to add 2 because, so 2 plus 2 would be 4. How would I get the next even integer, which would be 6? Well, I would have to have 2 plus 4 is 6. So if you notice, I have 2, 4, 6, 8, and so on. They're always going to be even. You always have to go up by 2 each time to get your consecutive even integers. It would also be the same if it said x was the biggest. You'd have x minus 2, x minus 4, and so on. So for example, if I started with negative 2 for x, I'd have negative 2 plus 2 is 0, negative 2 plus 4 is 2, negative 2 plus 6 is 4, negative 2 plus 8 is 6, and so on. So again, it doesn't matter what x is, you will always get consecutive even integers if you are adding by 2 each time. Let's look at odd. Again, you're going to start with x, and let's start with 1. Let's say x was 1. What would I have to add to 1 to get 3? Well, 1 plus 2 is 3. And you're like, well, wait a minute, that was even integers. Again, it doesn't matter whether you have even or odd integers, you're always going to have to add by 2 each time. So let me prove it to you with another integer. Let's say we had 5. So I plug in 5 here, and I want to get the next even integer, which is 7. Well, 5 plus 2 is 7. Okay, it worked. Let's see, 5 plus 4 is 9. So again, that's the next integer. 5 plus 6 is 11. Again, that's the next one. So again, even or odd integers, they look like the same formula. Okay, just don't mix up on your test, because a lot of people like to do this where they'll write x plus 3, because I'm talking about odd numbers. So I have to have 3, and then I have to have 5, and then I have to add so on. And it doesn't work that way. They look exactly the same, even or odd. It works both ways. They have to have even numbers. Okay, so we're going to be on page 42, and we're looking at number 6. I apologize, I said 6. I meant to say number 2. We're on page 46, number 2. So for your classwork tomorrow, you are going to be working on the odd problems. I am going to do all the even problems with you. So when you get stuck in class, you want to look at number 2 when you're stuck on number 1. When you're stuck on number 3 in the classwork, you want to look at 4, and so on. They are a match. They look very similar to each other and have a lot of the same concepts. So again, with page 46, number 2, I'm going to read it to you and make sure you're following along so you don't get confused. The perimeter of an isosceles triangle is 300 centimeters. So I'm going to draw an isosceles triangle, which means that these two sides are the same. You learned that in geometry. And the perimeter is 300, and it says, and its base is b centimeters long. So here's the base. How long is each leg? Okay, so let's look at what we know. We know that the perimeter is 300. We know that these two sides must be the same, so I can make them the same variable because it's an isosceles triangle. And the question is, how long is each leg? So I know if I have the perimeter here, I can add all these sides together to equal 300 because that's the perimeter. So perimeter means I can add all the sides together, so I add them all together, and we know that it's going to equal 300 because it told me the perimeter was 300 centimeters. Now, I'm going to want to solve for x. And I know this gets tricky because you have two variables in here. You have an x and a b, and you're like, well, how do I know which one to solve for? Well, what is the question? The question was, how long is each leg? So here are my legs, and X represents the leg. So I'm going to add those two legs together. I'm going to add those two X's together and solve for X so that I can find what my leg equals. So I simplified. I got 2X. Got to get X by itself, because again, the question was how long is each leg? So I have 2X equals 300 minus B. Divide by 2 to get X by itself. And I have X equals 300 minus B divided by 2. And you're like, well, wait a minute, that's not a whole number answer. And you're not going to get whole numbers in the notes today or in your classwork. You are going to get expressions. You can't fully solve them. You're just solving to get an expression by itself. So this is fully simplified as far as we can go, because we don't know what the base is. We solve for X, but we don't know what the base is. If we knew what the base was, we could actually get an answer, or a whole number answer, that is. Let's look at example number 3 on page 46. We're going to look at number 4 in your book. Number 4 in your book says Dan has Y cassette tapes. If he had 15 more tapes, he would have half the number his brother has. How many tapes does his brother have? So let's write down what we know. We know that Dan has Y cassette tapes. So Dan has Y number of tapes. And it says he has 15, if he had 15 more tapes, he would have half the number his brother has. So we don't know how much his brother has, but we'll make B equal the number his brother has. So this would be the bro's tapes. Okay. So we're going to have Y representing the number of Dan's tapes, and we'll have B representing his bro's tapes. So it says, I'll read it one more time. If he had 15 more tapes. So if Dan had 15 more tapes. So right now he has Y, but if he had 15 more of them, he would have, what did it say? He would have half the number, so half the number his brother had. So we would have half his brother's. So one more time. It said that Dan has Y number of cassette tapes. So we're making Y how many he has. And it says if he had 15 more tapes, okay, so whatever he has plus 15, he would have half the number his brother has. So we have made an equation here. And the question was, how many tapes does his brother have? So that means that we are solving for B, what his brother has. So in order to do that, I would multiply both sides by 2. And when you do that, you want to make sure you multiply everything over here by 2. Don't forget that. You can't just multiply it by y. So you're going to have to distribute it. You have 2y plus 30 equals b. And you can't solve that anymore, so you know that your expression is 2y plus 30 because that's how many tapes his brother has. All right, let's do example number 4. And we're on page 46 still, and we're going to look at let's go to page 47. And we're going to look at number 6. Okay. I will read it to you. It says the length, width, and height of a rectangular box are consecutive integers. So we're going to have to remember our formulas for consecutive integers. And the largest dimension is k. So that means we're going to be subtracting here because k has to be the largest. So we're going to go backwards. We'll have k minus 1, k minus 2, and so on. It says find the volume of the box. So I'm almost out of tape, so you're going to continue this on the next section. There's going to be one section for 1-8, and then there's going to be a part 2 for 1-8 because it only allows me to record for 15 minutes. So go ahead and start watching the next video.